Now I want to look at finding the domain and range of a graph. So let's call this example 1. Find the domain and range of the following, or of the graphs. We're going to look at a couple of these. So part A, here's a standard graph. The horizontal line is called the x-axis. So this is where our x values will be placed. And then the vertical line is our y-axis. That tells us if we're out here at this x value, how far up to go or how low to go. So let's just pick some points here. Say 1, 2, 3 in each. Let's go 1, 2, 3 in each direction. And let's say I have a point here, and then a point which is -3, 3, and it doesn't look like that. -3, 3. Let's call this one -2, 1. And let's say we have a point here and a point here. All right, so if you're just given a graph with these points on there, this is similar. This can be treated as the relations in the previous lecture. So all you need to know are what those points are. So this point here is -3, -3. This point is 2, 1, -2, 1. This point is 1, -1. And then label this point as 2, 2. So we have all of our points labeled now. And if we were to write this as a relation, all we have to do would be able to put these in those squiggly brackets, and then it would look like the example from lecture 1. So let's find the domain here. Domain, remind yourself of what the domain is. And if you don't know, pause the video and go back and read it. The domain is a set of all x values, or all inputs. So I come back over here and I see I have a -3, -2, 1, and 2. So that's my domain. I open it with a squiggly bracket and I get -3, -2, 1, and 2. All right, if you're comfortable, try the range by yourself. Pause the video and give it a try. I'm going to keep moving forward. So the range is a set of all y values. So the outputs, -3, 1, -1, and 2. So -3, 1, -1, and 2. All right. So the only thing I'd be careful with is on the homework. I don't know if the homework's going to want those to be in numerical order or not, or increasing order. So just be aware of that on the homework. Now let's change it up a bit, and we're going to make it, I don't want to say harder, but it's going to add an extra step or two in. And instead of just looking at individual points, let's look at a continuous graph. So here's part B. And this is your x-axis. It's good habit to write x-axis and y-axis every time, because later on we'll get into the scenario where we have a lot of graphs and lines going everywhere, and it's helpful for me to know that you know what you're doing. All right. So let's say we have something that looks like this. Okay? And I want to know the domain and range of this graph. So we need to first start off finding the domain. Now here we don't have discrete points like we did earlier, where we just labeled all the points. Here we have infinitely many points. So we need a way to condense that and write it in a smaller form so everybody knows what we're talking about. So the domain remind yourself of what the domain is. It's the set of all x values, all the inputs. So all the values along this x-axis here. Now this down arrow, it means it just keeps going forever. So it keeps going forever in this direction and in this direction. So let's just focus on the x values. That down arrow, it keeps going forever in the x direction, the negative x direction. And then over here, this arrow means the same thing. It goes forever in that direction. And forever, we call that infinity. So our x values go to infinity this way, and they go to infinity this way. This way, we call it negative infinity. Okay, so we got that out of the way. So how do we write it now? So when you're finding domain and range of a graph like this, you want to start with the smallest x value, or the smallest value that you're looking for. So we come over here, and we go along our x-axis, and then we see that this just keeps going forever, so negative infinity is our smallest value. So we write negative infinity. And then we're going to have parentheses here. And then we go to the largest value, largest x value, which is positive infinity. And then another parenthesis. All right? And later on, we're going to learn that we don't use parentheses all the time. And I'll show you an example here in a minute. But for infinity and negative infinity, we always use parentheses. Okay, now the range are the set of all y values. So what is it works the same way as domain. You find your smallest y value first, whatever is the lowest, and then you work your way up to whatever the highest value is. So this arrow keeps going down forever to negative infinity, comma. Then it keeps going up forever on my y-axis. If it helps to run your finger along the y-axis to see where it goes, then that works too. It goes up to infinity. And again, parentheses there. Okay, now let's look at what I was talking about in a scenario where we don't use a parenthesis. And that means that we would be including those points. So let's look what I mean. Here's my x-axis and y-axis. Let's go 1, 2, 3, and 1, 2, 3. So let's say we have a point here, and it's a closed dot. All right, and then it comes like this. So it just touches this point here. I'm not going to draw a dot because there technically wouldn't be one. But just for the sake, because I'm a terrible drawer, it actually does touch this point here. All right, so let's find the domain. All right, and in your head, just before you write it, because the writing can sometimes be the confusing part, just look at it and look at all your x values here. See which x values that you're using or that the graph uses. So start with the smallest. So start over here and come to the left until your graph doesn't use any more x values. And notice that the graph stops here. So this is the lowest x value that this graph uses. That value is -3. All right? That would be your smallest value. And then come to the right and see where your graph stops, or all the x values that it uses, and it keeps going to infinity there. So my smallest is -3, and it goes to infinity. That's my domain. All those numbers in between there. Now, you're going to write it very similar. The smallest value is -3, comma, to infinity. We already know that we use a parenthesis on infinity. Now that -3, we can't use a parenthesis because that means to not include that point. Here, it's a solid dot, so that means to include that point. If you're using include, that means it's a bracket. All right? And I'll get to what it means if it's not a solid dot here. I'll show you that in a second. Now range, give this one a try by yourself. All right, so my range, my y values is here. My smallest value that this graph uses stops here, stops right here. And there's going to be more lines, but my graph stops here, and this value is -3 again. All right, this throws some students off because it's kind of a curve and it's weird, but you're only focusing on the up and down here. My graph stops using y values right here. That's my lowest, -3. And I'll get to the brackets and parentheses in a second. And then my highest y value, it just keeps going up and up forever. So that's to infinity. I know I used a parenthesis there. What about this point? Since there's no dot, there's no open circle, there's nothing here except the graph. It's just continuous. So if you're in this situation and you don't have a dot and there's not an open circle, then you use a bracket because you need to include that point. It is part of the range of this. So just as a side note, let's look at if this was an open circle, just like that. It might be a little hard to see. I'll draw it a little bigger. That's at -3 still. If it was an open circle like this, then your domain and range would change. It wouldn't include, you wouldn't be using a bracket anymore. You would be using a parenthesis. So it'd be parenthesis -3, comma, infinity. And this would be parenthesis -3, comma, infinity. All right? So if you have a filled in dot, that means you use brackets on either side. And if you have an open dot, that means you use